value of x is equal to 4. Now you know already when it's our simultaneous equation, although I'm saying it because people may say, Miss Weston, for you that's easy, but I need a little time. So again, I'm going to give you a water break to concentrate and to see exactly what I did and what I said before I continue to find the value for y. So we'll be right back.
Whenever possible, draw a diagram. Even though you may be able to visualize the situation mentally, a hand-drawn diagram will allow you to label the picture, to add auxiliary lines, and to view the situation from different perspectives.
Okay, so we're back, and you had a chance to look and to see. So this time you were given the equation 4x minus 3y is equal to 1. X plus 3y is equal to 19. And we looked and we saw that in the y's, the coefficients were identical, the signs were opposite, positive and negative, so we could get our 0 that we're always trying to achieve to eliminate one of them. And we went right away to say equation 1 plus equation 2. And so we did our addition and we got our 5x is equal to 20. And then we said we don't want 5x because it's 5 times what we want. And so we said to get it to 1x, we have got to divide both sides by 5. And then we see that x is equal to 4. This is now our equation 4, okay? We're going to use the value in equation 4 for x and go back to our original equations. And we're going to see which one we're using, substituting in it to get the value for y. Now, which one should we be using? Oh, we have 4x minus 3y is equal to 1. X plus 3y is equal to 19. Which one would you be using? Does not matter, but you're right. I would use the one with 4x minus 3y is equal to 1. Or you're going to say, no, I don't want to use that. We will use both of them to show you, okay? So here we go. From equation 1, using, and we don't say using, we say substituting. So let's use the right term. Substituting for 4x gives, and we're going to get that it is 4 times 4 minus 3y would be equal to 1. All right, so here we're going to get, then it is 4 4s would give me 16, and it's minus 3y is equal to 1. We want to keep all the y's on one side, so we have negative 3y is equal to, and it implies, and we're taking the 16 over to the other side, the 1 stays, 16 comes over to the other side, so it's minus 16, we change our sign. So we have negative 3y is equal to negative 15. And again we say, when we have negative 3y is equal to negative 15, we do not want to find a negative variable. So we're going to change the signs. So we're going to get plus 3y is equal to plus 15, because what we do to one side, we must do to the other side. Good. Now again, so we're just writing 3y is equal to 15 because we understand that it is plus when we don't see the sign. And then we can get right away 3y divided by 3 would be equal to 15 divided by 3. So we do our cancelling and we're going to get y then is equal to 5. Y then is equal to 5. And so our solutions are x is equal to 4 and y is equal to 5. But I promised you that I would have substituted in equation 2 just to show you that you would have gotten your same value if you used equation 2 instead of equation 1. So let's see if this is true. Okay? Now, if I had used for my substitution equation 2 and said the same thing, substituting 4 from equation 2, substituting 4 for x, this would be giving me that it would have been 4, and it is plus 3y would have been equal to 19. All right? And then I would have gotten then that it is 3y would have been equal to 19, and I'm taking the 4 over to the other side, so I'm changing my sign, so it's minus 4, and then 3y would have been equal to 15, and we can say 3y divided by 3 would have been equal to 15 divided by 3, and yes, we would have gotten again y is equal to 5. So it does not matter which equation you are using. And I have a big secret for my primary school students, because you too can do and would sometimes be given the option to do what we are calling simultaneous equation. Yes, in your primary department, you too are using simultaneous equation. And it comes when your teacher says the sum of two numbers is 27. And I can say to you, we can call the numbers A, and B, and so it would be saying A plus B is equal to 27. Because I know you do that in your primary schools, okay? And then it says also, and their difference is 3, okay? And their difference is 3. So again, it would be A minus B is equal to 3. Did you know that you were doing simultaneous equation? Yes, you too would be involved in simultaneous equation. So mothers, you can help your students now, because it is in fact right into the realms of simultaneous equations that these primary school teachers were taking your students and your daughters and sons and did not know that. But now you know it. You can do it with them, okay? Because we see right away, you can just stop and tell yourself, but this looks like something that I saw already. And yes, it is called simultaneous equation. And you do it like that. The sum of two numbers equal 27. Let the two numbers be A and B. So you have A plus B is equal to 27. Their difference, so when we subtract them, A minus B is equal to 3. All right? And we're in the same realms of simultaneous equation. So what would we be doing? We'd be looking and saying plus B minus B, we can get rid of that one. Isn't that true? So again, we are saying equation 1 plus equation 2, and that would be equal to A plus A would give me 2A. The B's would disappear, and it's now equal to, if we add it, we're going to get 30. So we have 2A is equal to 30. We don't want 2A, we want 1A. So we're dividing both sides by 2, all right? And that goes, and we're saying 2 into 3 goes once and 1, 2 into 10 goes 5. So we get right away that A is equal to 15. Look and see if you can do it. Next time, we will be back to work one of these, because we are going to master mathematics in this country. Good evening.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.